Hi everyone, welcome to today's webinar on inline color measurement and closed-loop color control in the laminated paper industry. I'm Robert Grotans, the Global Technical Marketing Manager at X-Rite. I will be moderating today's webinar. Presenting today is Manfred Binder, our Sales Director for Inline Color Measurement Systems. I'll turn it over to Manfred to kick things off.
So hello everybody. Let me show you why it is so important to make a color measurement in the laminated paper industry. If you look at these boxes, we have different colors of the boxes here. Basically, the content of the boxes is most likely the same. But would you trust in the quality? Or if you look in these boxes, always a small and the big box belongs together as one piece. Do you think that the color of the content of the boxes is the same? So which boxes would you pick? Or look at these folders here. Does it look nice if they are in the shelf like this? So we see color immediately. Even if we are not specialists in color, color is a primary quality criteria. That means if we look at the colors, we immediately see if something is wrong. So these were just samples from other paper industry, but today we are talking about laminated paper. Look at this kitchen board or at this kitchen fronts. You see there is one door looking a little bit different than the other ones. So would you accept the kitchen like this? So color is very critical because we see it immediately. It's the first impression what we get when we look at the product, even before we touch it, even before we smell it, if we taste it or whatever. So how do these color deviations occur? If you look at the raw material, so especially in the laminated paper industry, if you have a pulp from different sources, if you have different fillers, titanium dioxide from different mines or whatever, if you have additives, retention agent fixatives in different amounts in your pulp, if the pH value is changing, if you dilute your colorants and you do not always these perfectly in a perfect concentration, all of these will influence the color. So at the beginning of the paper machine, you always have different color variations, but at the end, the finished paper must have a constant quality. So this is the most tricky part for the paper makers. If we talk about color measurement, we not only measure the color. So for some papers like laminated paper, kraft liner, test liner, we only measure the color. But if you look at newsprint, tissue, or cardboard papers, or graphic coated or offset papers, we also measure the opacity. And of course, if it comes to white papers, then we also measure the whiteness. In total, we have over 700 successful installations in paper. Successful because all of our installations are successful. That means if you know somebody who is using our system, go and ask these people. I know paper makers have a very good network. So if you know somebody, ask them. Everybody loves our system. If we have a problem, this could happen, of course, we solve it immediately. And you see we have over 1,000 successful installations in total. That means approximately 300 installations are in different industries like coil coating, plastics, or whatever. So our main market is paper. Why do we do an inline color measurement? Well, the inline color measurement gives you early results on the color, what is on the paper, on the machine. So this helps you to have shorter startup times and shade change times. I will show you later on in a graph how this looks like, especially for laminated paper. And of course, if you are much quicker on color, you have less waste. You can react immediately if there happens something on your machine, even before you are out of specs. And you have the documentation of the entire production like it is recommended in ISO 9001. Why is this so important? If you normally have a roll of paper, you only can check the beginning or the end of the paper. So nobody knows what is inside. It happened that customer complains that they say the beginning at the end of the reel was fine, but right in the middle we had some color variations. So we have to reduce the price of, I don't know, 10% or whatever. Only if you have an inline color measurement, you can prove how the quality of the whole reel is. And of course, you need an inline color measurement to make a closed loop control. If we talk about a system means you have not, it's not only that you have just an instrument and a piece of software. No, we have much more. We have typically a whole frame which is mounted to the machine, so it's a customized frame. This frame is controlled through several boxes. So we have a frame control box, we have a power supply which gives the power to the instrument and to the frame. And then we have a long distance to the control room, which is typically made through a CAN bus. So this could be up to 500 yards. And close at the computer, we have another box which converts the CAN bus signal to USB. So the big advantage is you can have a regular computer, you just need a USB port and you can connect everything. If we have a closed loop control, we also connect here this box to the dye pumps. So the dye pumps are in the dyeing room, which is maybe also far away. And these dye pumps will then feed the paper or the color to the paper. And of course, you can have a optionally connection to the DCS system. So if you want to share the LAB values, what we measure on the machine, if you want to connect the pumps directly to your DCS system, we can communicate to your system and exchange the values in both directions. So this is how a system looks like. If you go now to a paper machine, I have here a very simple paper machine. So we have just one pulp chest over here. We have a fan pump bringing the pulp onto the machine. We have the screen section, press section over here, drying section, and the reel up. The first position where you can measure is typically here in the pulp. And this is also used very often in the laminated paper industry. If you measure in the pulp, unfortunately, the color values are not exactly the same like on the finished paper. Here we have also water inside, so the pulp is much darker than the finished paper. You will get different values, but if there is a change in the pulp, you can be sure that there will be a change on the machine. So we call this a kind of early warning system. Theoretically, also optical brightness can be measured over here, but in the laminated paper industry, this is not so much used. How does it look like? So we have our instrument right in a box. You have here a U-tube where the pulp goes through. So we have always a bypass on the machine. There is a window over here. And due to the construction of this hose, the window always stays clean. So you do not have to clean it externally. Why do you use it? So let's say we have here the machine chest and we have here our system to measure. What you can do is if you have two different flows of pulp, let's say a cleaner pulp and a more dirty pulp or whatever, you can adjust these two pulp flows to get here to a certain color that always the pulp which goes to the machine is constant. And even more used in the laminated industry, if you make your mixing by hand, then you have a mixing chest, you put in your colorants, you put in your additives, you mix it up well, and with the system you can see, first of all, if one batch has exactly the same color than the next batch, because sometimes it happens that you do the darkest color at the end, you could forget it, or you could not have exactly the same weighting amounts, then you will see you have a variation, and for sure this variation you will have on the machine. So you can be sure that each batch is the same like the other one. And of course, if you want to make corrections, let's say you know that you need to make a pulp 0.2 units more red, then you can add more red and you see immediately how the pulp reacts and how long does it take until the mixing in the chest is constant. You would see all the variations on the other side on the machine. So this is how it looks like. It's just a box which is mounted very close or directly at the mixing chest. We have here a second possibility to measure, and the second possibility is between the press and the drying section. So we measure the wet paper. Why do we measure the wet paper? If you look especially to the laminated industry, normally we do not care about how the paper looks like, but we care about how the paper looks like when it's laminated to a piece of wood or board, whatever you use. So here in this case, at the left-hand side, we have a standard. On the right-hand side, we have the sample. And then we compare whether the color is the same and even the opacity is the same. So here is a black stripe below. The tolerances are very tight. Typically in laminated industry, we have LAB tolerances below 0.2. So this needs to be very accurate. And now the question, why do we measure at the wet end? Because when you drain the paper with melamine resin, it's changing its surface, it's changing its optical properties. So when it's drained with melamine resin, it's quite similar, like on the machine when the paper is drained with water. The water has approximately the same refractive index than the melamine resin, and this helps us to have a very good correlation to the paper which is laminated to wood or something else. So this is the reason why we measure laminated paper always between press and drying section. Only, or let's say the third point, what we can measure is right at the end before reel up. This is normally for all the other mills the most used location where we measure the color because we measure the finished product. For the laminated industry, we only use it if we have pre-impregnated paper, as the paper is already drained with the resin. So then we can measure really how the laminated paper looks like. And here, of course, we have a very good correlation to the laboratory. Yeah, and optical brightness could be measured as well. Just some pictures how we install this system. So this is an instrument on the machine with a frame from us. Sometimes we get the question, do we need a single point measurement or a cross direction measurement? Most of our competitors have a cross direction measurement. Why? Because all the other parameters need to be measured in cross direction. If you have a moisture profile, if you have a temperature profile, a thickness profile, whatever, all this changes in cross direction. There are just a few parameters which are not changing in cross direction. Nobody is measuring the speed of the paper left, middle, right side because there is just one speed. And the same is for color. If you put your dyes into the chest at the beginning, you only have one color in the pulp. And let's assume we mix it up well. You have no chance to say, please, your left pigments, you go to your red pigments, you go to the left-hand side, and the blue pigments, please, to the right-hand side. So you have one pulp, you have one color on the machine. The problem is everything influences the color. So like moisture, thickness, opacity, or temperature. If you have a moisture profile, of course, the color will change a bit. So if you make a cross profile measurement, you will get different color values, but these are not caused because of wrong color. These are caused because of moisture differences, thickness differences, opacity, or temperature differences. So this is the reason why we say measure one point at the machine, and then you can see what on this point, your temperature, color, what temperature, moisture, opacity, whatever is, and then you see whether your measurement is correct or not. So it's a big advantage to make a single point measurement compared to a cross direction measurement. This is an installation which we have at camera. You will see later on some more facts on camera. I'm allowed to show this because they have made a speech on a show, which I'll show you later. So this is very popular, very, very interesting here. So this is an installation. At the end, they have a pre-impregnated paper. This is another installation, and you see the instrument over there. I use this picture always to show you we are very close to these scanners you have. So most of the mills have already scanners, sometimes even with color measurement on the machine. Our measurement is much more precise, most of the people really rely on our measurements. This is also one of our measurement heads. It's not in the laminated paper industry. Honestly, it is in a tissue industry, and tissue is very, very dusty. So you can see the instrument is dirty. This is in parking position. So normally we swing the instrument away if there is no paper on the machine, just to feed up the fresh paper and have enough room if the paper is fluttering a bit. Over here is the measurement spot, and you see it's at the moment closed with a lid. So no dirt can go in because it's closed. Only for the measurement, we open the lid for a very short time, make a flash, and then we close it again. During this time, we have an air purge over here. So there is an airflow going in and it keeps everything clean. There is no dirt inside of the instrument, even when it looks outside a little bit dusty. So it works in rough environment. And if we talk about laminated paper industry, normally we recommend to calibrate the system, make an external calibration every six weeks. And then you can have a look. Maybe you have to clean the instrument from inside, which is very easy. There is just one screw which you open and you can open the lid, clean it from inside. Most of the time, the instrument is just cleaned once a year when our service technician comes by. This is how it looks at the software. So if you have a color measurement, it looks like this. You can have up to 6 graphs. Here we have only 5. So most of the times we have the L value over here. We have an A value over here, we have a B value over here. And in this case, we have the delta E and we have an opacity over here. It's very easy to see where you are. The color of the bars shows you if you are too light or too dark. So at the moment, we are too light, too green, and a little bit too yellow. At this place, we were too dark, too red, and too blue. So it's quite easy to understand where your color is. Here we were very much, or a little bit more to yellow, so you see it's just 0.5 plus minus. You see at the first glance where you are, and you can, if you are out of spec, you can make the bars red for the opacity in this case, for example, so you see immediately where you are. Now, we talk about how to save money, especially in the laminated industry. If you make a laminated paper, what do? Typically, you produce a pulp and then you produce a stripe on the machine. So it takes a certain time. After that time, when you have the stripe, you take a sample, you go to the laboratory, and you have to laminate this stripe with the standard together on your wood. So this lamination process takes 20 to 45 minutes. It depends how you do it. After you have done this lamination process, you can make the first measurement in the lab. And then you see where you are, and you do have to do a correction. So you make a correction on your machine, and you produce another stripe. Then you take a second sample, you go to the lab, you make the second measurement, and if the lab says okay, you can start your production. So this is the time, how long it takes to set up a machine. And it's not unusual if you have very low lots to run, that you set up the machine for 1 or 2 hours, and then you produce the good paper in 20 minutes, half an hour. And then you have to set up the new color again for a long period of time. You can reduce this time if you have a reliable color measurement. So but it needs to be a reliable color measurement, yeah, not just something. We cannot avoid to produce the first stripe. I think then we have, but we have already here inline measurement. So then we come and make the first correlation to the lab, and then we see where we are and what needs to be corrected. And I can correct and produce the stripe directly on the machine. And with the inline color measurement, I see directly where I am. So when I recognize I need to be, let's say, 0.5 units more red, I add more red. As soon as I have the 0.5 more red, I can continue my production. I take a sample here to verify in the laboratory, but I have the good production from now on because I see whether it's just 0.1, 0.2, or 0.5 more red. So with a little bit experience, I can even manually go very quick to the right color. So basically, This period from here to here is the time where I have already good production. So this helps me to be much quicker on the color, to reduce my transition times, and to have more good production. So what I told you now was just with the color measurement. Now we go and talk about the closed loop control. If we have a closed loop control, we measure somewhere on the machine. Here I made it at the reel up, but you can also measure over here between press and drying section. So we measure our signals, we bring it to the computer like you have seen before, we show where the color is. And then we know what are the target values and where are we. And with a calculation, we send these information forward to the machine where we have some pumps. And these pumps go in here, and then we add the dyes that we need to achieve the right color. If we make dark shades, we can also use a kind of pre-dyeing, so we can put the dye into the chest to get to, let's say, 80–90% to the color. And the closed loop control will just do the 10% here in a closed loop control mode. What makes it so difficult to go to these colors? I have shown here as examples. So we typically have the LAB values. L is light dark value, red green is the A, and yellow blue is the B value. So what everybody likes to have is one dye which is influencing just the L value, one dye influencing just the A value, and one dye influencing just the B value. But you can imagine that the blue is not only for the L, it will also change the B value. And if it's a reddish blue, it will change the A value as well. So each of these colors will change all three axes. And this makes it complicated because you do not know whether you have, if you want to be more blue, you can reduce the yellow or you can increase the blue. Both will have complete different reaction on your LAB system. So when we do this mathematics, we have a model-based closed loop control. That means if you use conventional controllers like PID controllers or other things, you cannot make it because they will influence all axes to each other. They will control against each other. So we need a model-based control system. Basically, it's a color recipe system like people in the laboratory use to get to the right color from their basic colors. With this model, we can calculate the dye adjustment, let's say, of all three colorants at the same time. So we do not say we need to get a little bit more reddish, so we add more red, see what happens. Now we have to go a bit more bluish and we add more blue. And then we see that we are too dark and we distract something from it. We calculate all three dyes at the same time. Normally, we have parameters inside that we can go in one step to the right color. But what we do is normally we try to be a bit more conservative. So we do not set up the gain to 100%, means to go really to the right color. We set it up to 70% to take 2 or even 3 steps to go to the right color, not to overshoot. And of course, if we have made a change on the dyes, it takes a while until we see it at the end, and the next control step will be done after we have seen what happens on the machine. What do we need? So if we really go for a closed loop control, we need to have a continuous coloration of the pulp. That means we need to have somehow liquid dyes or liquid pigments, so a slurry. And we need to pump these dyes to the process, typically right in front of the fan pump. There are different pump types which you could use. I have just made here some assumptions. So we can use piston pumps, membrane pumps, mono pumps, peristaltic pumps, gear pumps, and everything which is on the market, as long as we can remote control them. That means we give you a signal, could be 4 to 20 milliamps, or it could be any other signal, whatever. And then we need to control the pumps. So the pumps can be on your side already existing, or we also can deliver a full system, including pumps, and do everything by ourselves. The good news is If you use certain dyes, you do not have to prepare any calibration samples like you have to do it in the laboratory. As we are just making the, let's say, the correction on the machine, we are very close to the color, and then we need just to correct it. We have all these databases for all the dyes which are on the market ourselves. So if we come over for the installation, we bring this with us and you can start working. What is necessary to have a good control? If you have 3 colorants, then we can for sure go to the right LAB values if it's physically possible. So if you have 3 blues, we cannot make a red for sure, but if it's a right selection, we can go to a delta LAB of 0. If you have less than 3 dyes, a closed loop control also works, but then you have to decide what you want to reach. For example, we can say we want to reach the lowest delta E, or we want to have delta A and delta B on 0, and we float delta L, whatever. So even less than 3 dyes are possible. And the dye stuff supplier is responsible for the injection point where we inject the dyes. This is necessary because he knows how long do we have a contact time from the dyes or from the pigments to the fibers, that everything goes smoothly on the machine and is nicely mixed. So what are the advantages of the automatic closed loop color control? It provides an on-time process correction. That means you do not have to do anything. You just press a button and it goes to the right color and it keeps the color constant. So this minimizes startup and shape change times dramatically, as I have shown you before in the graph. It minimizes off-spec production. You will, if you are on color, closed loop control will keep the color constant, even you have some shifts in the raw material or whatever. It improves for sure the product uniformity. Optimizes the dye usage, so you will never have an over dyeing or something like this. And I think very important, it takes the guesswork out of the process. What does it mean? I mean, even if you have an experienced person who knows how to dye, this person knows we have to add 3% more blue and reduce the red by 2%. But is it the right 3% or maybe 2%? Now let's start with 1% and then we make another 1% and then we make another 1%. So typically it takes some steps until it's really on the target. With the closed loop control, we can calculate that we need 2.8% of blue and minus 0.18 in red to go to the right color. So it's calculated, it's no more a guesswork. And especially during startup or shade change, the operators can focus on more optimization. So during this period, you always have to do adjustments on your machine. The color is always done typically when everything else is done. So this helps you really to be quick on color without having labor work in the process. And of course, it minimizes the need for tear out samples, because if you know where you are and where you want to be, you see immediately if your correction which you have made on the machine is going to the right direction and is enough. I told you before that Kemmerer, which is a German laminated paper producer, he made an article, and what I show here, I'm allowed to show. So these are facts from the presentation of Kemmerer, which was a public presentation at the International Paper Symposium 2018 in Munich. So the motivation for Kemmerer was the color evaluation without inline measurement is time and cost intense. So you need to take a lot of time to go to the right color. They need to reduce their broke. They need to minimize, let's say, and analyze the parameters which will modify their colors. And they think that the movement of the paper through the machine is very stable. So they do not need to focus on the machine settings. So this was the beginning when they started. And this is how it typically looks like. So you have several pieces of paper, you look at them, and one person is judging whether it's a good color or not. The problem is, if the person has a good color view, then it gets to a certain result. But if you have 3 persons, maybe you have 3 different results. And today you like it, tomorrow you do not like it. So this is very subjective. You need to have more results to do a assumption what is wrong. So what they did, they invested in laboratory equipment and they invested in inline equipment, and then they figured out what happens on the color if they do some changes and what will be seen how. So they figured out what do they need to measure to get to the right color. So they installed a closed loop color control, and the statement from the camera was so this is original from their presentation. The closed loop color control system lead to a significant reduced workload and a person independent evaluation. So they can now produce the paper without this guesswork whether the color is right or wrong, or how much do we have to change. The broke was dramatically reduced, which is also very important, because if you have a broke, you have to store it, you have to reuse it. The broke you do not produce. You can produce good paper, you do not have to store it, and you do not have to reuse it. You always have fresh material. The color consistency within a run is much more stable. Of course, this is what a closed loop control is for. So even if the raw material is changing, the color is constant. The color values match to the pre-production quite well. So every time pre-production, they meant the previous production. So if you make a color today and you make a color tomorrow, it works quite well and you have the same color. They could increase the amount of broke usage. So even the broke they have on stock, they were reusing it, and they planned a broke handling concept, so to reuse this broke. I will try to go a little bit into color formulation. You remember these graphics which I've shown you before? If you save only 15 minutes, this is an ROI calculation. And I assume if you save only 15 minutes for each color change, which is not that much. And if you have only 2 changes per day, there are a lot of companies which have 8 or 10 changes per day. If you have only 300 working days per year, and if you have machine cost of $2,600 per hour, which is not very much, you can calculate 2 times 15 minutes, which is 0.25 hours, times 300 days, times 2,600 euros. You will save dollars. You will save $390,000 per year. So this is a very easy calculation for the return on investment. And you will see it's always worth to invest in color measurement or closed loop color control. This is another calculation from a company. They made colored papers. It's not laminated paper, but it's a colored paper as well. So they use a lot of dyes. They produce 25 tons per year. They have approximately 310 working days per year. They have approximately 1,000 changes per year. They saved with they had just pulp measurement, so only measure the pulp. They saved 3 minutes per shade change, and this was at a presentation in our seminars, which I'm also allowed to use, of course. And they say our turnover is 700 euros per ton. So if you calculate this, you will save approximately 3,000 minutes per year, and with the profit, that means you have 39 euros per minute. So euro and US dollar, it's I would say nearly the same. You can say this is also the same in US dollar. If you make now a return on investment, that means they have saved 117,000 euros per year. That means they had a return on investment in 9 months. What they did not calculate was that they have less waste, and what is even more interesting for them, they have less waste handling, because all the waste you have to take, you have to store somewhere, you have to reuse it. So this was a big factor which they did not calculate in this ROI. And of course, they had less complaints from customers. I have another example here from Lenzing. This was published in a paper as well. So they have different processes here. So they have one pulp line going over here, which has envelopes. Then they have a second line over here, which is making printing paper. Not making, which is using printing paper for a waste or for recycled material. And they have another line over here, which is white, not printed clear waste. And over here, they have virgin fibers. So they have 3 color measurement systems. One is over here, one is over here, and one is at the machine. So this system is used basically for the forklift driver who is feeding this pulper over here. The time from here to here is approximately 20 minutes. So here the forklift driver can see if the pulp becomes too reddish, he is using less of the red pulp. So he's using more greenish, more bluish, more yellowish pulp. So this helps to get a nearly constant color in this pulp line over here. The time from here to there is approximately 4 hours. So there are big chests over here where the pulp is stored. And this one is for the machine operator here because he sees immediately which pulp comes over. If the pulp is too dark or too much colored, he can open more of these clean pulp flows and get more pulp inside over here. And of course, you have at the end an instrument to control the color of the finished paper. Their goal was to achieve at least 63% of the total production must be recycled material, and they could manage it. So the effects from Lenzing, they said we have to minimize the waste usage. We have to maximize the usage of waste, right? We have to shorten the transition times before. So before they had these instruments, they used 30 to 50 minutes for going from one white to another white. So this is a white paper here. And after they needed 15 to 20 minutes. And you see the gap is much closer and it's at least 50%. The load relieving of the operators during the state change was much less after it. They do not have to take samples now. They just really rely on the inline measurement. They have tighter production tolerances, which helps the marketing to sell and keep their prices up because they can say, our quality is very constant. You do not have to give reductions because of color variations. And it's always difficult to get real numbers for a return on investment. So we always try to ask the people how quick did it pay off or whatever. And this guy told me, you can imagine that every instrument has paid off very quick. Otherwise, we would not have bought a second and a third unit. That's correct, yeah. So here I have some more statements from Leiper Schrobenhausen. And I think everything is published here. So you see the name, it's Mr. Kaltenecker from Leiper, Leinfelder in Schrobenhausen, Germany. The reduction of waste during grade change was 25 to 50%. So this is a very nice number. You can see this also on our homepage. They are making colored paper. Then here we have somebody from brown paper, unfortunately, but you can imagine brown paper, they have every garbage they have, every recycled paper they use to make their brown paper. And even with these color variations at the beginning of the machine, they have delta E values of 0.1 to 0.2. So the beginning of the machine, the raw material has huge variations. And at the end, we have only 0.1 to 0.2. That's really perfect. And very little maintenance effort is required. And the last but not least, last one, since we started using the inline closed loop color control from X-Rite, we have no more complaints about color from our customers. And this guy was making white paper as well. I just want to show you in one of my last slides how we do a typical installation. So on day one, we built the color measurement system into the machine. So we need 2 hours machine shutdown. Then we go into the machine, we make everything of the mechanical stuff. After 2 hours, this should be, or even quicker, it should be finished. So you can start on the machine. The rest of the installation will be done while the machine is running. At the end of day one, the color measurement is running and we will run it overnight. Day 2, we need as installation for the pumps. So that means we install the pumps itself, we make the connection to the computer, we set up certain parameters to let it run. And then it's a question how much we rely on this installation or on this closed loop control. Either we let it run overnight in automatic mode and show the operators what to do if something happens. If you're not 100% sure, we just let the color measurement run without the closed loop control. And on day 3, we finish the installation. We make the training for the measurement, typically for 3 shifts. And then the machine is running in closed loop mode. And on day 4, we just be there for fine-tuning the system, for getting help if somebody feels uncomfortable or whatever, or training other shifts. The cost of the instrument is very, very low. So every 2 weeks or every 6 weeks, depends, you should make external calibration, which takes approximately 30 minutes. But these 30 minutes is really calculated to get a white tile somewhere from the operator's room, go to the machine, you put it on the instrument, and then the calibration itself takes only 30 seconds, and then you bring it back. So it's very little time consuming. We recommend that every year a service technician will come on site, and he will clean up the instrument. He will do some service and test measurements whether the instrument is measuring well. And of course, you get the ISO 9001 certificate. These instruments are a long-term investment. We have an instrument from 1990, which is still in operation. So you see, it works for a long time. The availability is very high, typically above 99%. And as I said before, we have many happy customers. If you know somebody who is using our instrument, ask him. This is really a good recommendation for us. If you need more information, you can go to our homepage. Unfortunately, at the X-Rite homepage, there is not so much, but we have a homepage which is called www.erx50.com. Here you find everything about paper measurement and also something about other applications. Thank you very much for your attention. Are there any questions?
Perfect. Thank you, Manfred. It looks like there are no questions at this time, so we'll wrap it up here. You will receive an email with the link to this recording. I just want to say thanks everyone for joining and have a great day.
Thank you. Bye-bye.